right. Good morning. So, as said, test is Friday. Okay. What? Friday.
No, I thought it was earlier in the week.
Oh no, Friday. Friday. So today we're going to handle graphing linear inequalities. Wednesday we're going to graph absolute value inequalities. Thursday we'll review all things Unit 2, and then Friday we'll take the test. So you should have picked up a pink piece of graph paper for today, and you should have picked up a white homework packet for this week. I know, it's a packet this week. Normally we're just front and back, okay? I get that, but people have been like crabbing that I don't give them enough space to do their work, and then there were graphs, and next thing you know, it's 4 pages. Oh, 100% her.
Yeah.
Yeah, that's why I looked right at it when I said it. So, yeah.
Mm-hmm. Mm-hmm.
So, and that's why you just gotta keep reminding me, give me more space to work. I have no problem. I have no problem cutting the tree down. Okay. Turning it into pulp and making it be paper. Okay. Right. Any other questions for the greater good of the greater good? All right, let's do this. Let's graph linear inequality today. Okay. So there are 2 steps, and each one has a figure. So, and we gotta do both of them. So the first step when graphing a linear inequality is we need to get ready to graph the line. And the way we go about getting ready to graph the line is we think about it as if it were an equality. Okay? So it might be 7x plus 4y is greater than or equal to 14. Okay? How you treat that is you think of it as it was last week when we were graphing lines. And remember from last week, we've got 3 different ways to graph a line. You could get it y equals mx plus b, plot your y-intercept, and use your slope as rise over run to find a couple more points, draw in your nice straight line, move on to the drawing. Okay? You could do a t-chart. You could graph an intercept with. Okay? So there's multiple ways that you can do all of those. Okay? But the first thing is we think about it as y equals mx plus b. Now, here comes kicker. Okay? So the line that you draw is going to either be dashed or solid. Okay? So it's going to be solid if we are dealing with the less than or equal to or greater than or equal to ones. The filled in dots from before when we were doing just simple inequalities, the filled in dot inequalities, those are your solid lines. Your dashed lines then are the open dots, or the just the greater than or less. Okay? And that is going to depend upon your inequality. Now, some of you are pen type workers, okay? And that's fine. But when you go to draw the line, make sure you know what kind of line you're drawing so that you don't have to go back and either use a whiteout stick or have to erase if you're a pencil type person. Okay? All right? I just happened to see that you were using a whiteout stick. Yeah. Or the worst part is like you try and do it over the top of what it is, or you have to draw an arrow like this should be a dashed line and all that fun stuff. So yeah. Second step is we are going to shade, because we're in an inequality, there are going to be multiple there's going to be multiple points that make that be a true statement. So we're going to shade the area that contains all those points. Now, for me, I'm a test point type person, okay? Where I pick a point not on my line, and I plug it back into my original inequality, and it all depends on the truthiness. If it's true, I shade on that side of the line. If it's false, I shade on the other side. Okay? Right, you look a little confused by that.
No, I
Okay. Because the next slide is going to just be a test of the test points. Now, does anybody know the easiest test point to test? No. Even easier. Not just 0, but the point. 0, comma 0. Yep, the origin. The origin is the easiest one to test, as long as you don't go through the origin. If you go through the origin, you can't use that. Then we would use either 1, comma 0 or 0, comma 1. But it doesn't have to be. It can be any. Okay. Okay. Let's try testing. Okay. So, checking solutions, testing a point, finding the truthiness, whichever one you want to call it. Okay. So it's telling whether the given ordered pair is a solution of the inequality. And you do that by plugging in that point back into your, come on now, there we go, and finding out the truthiness. Okay? So we'll try 0, comma 0 first. So I plug in 0 for y. I plug in 0 for x. And I go about my business. 0 is 0. 2 times 0 is 0. Plus 4 is 4. Now I ask myself, is 0 less than or equal to 4? Yes or no? Alligator or crocodile, remember, it's a bigger number. Is 4 the bigger number? Yeah, yeah. So that is true. So yes, 0, comma 0 is a solution. Okay. You now, same inequality, you tell me, you tell me if negative 2, comma 10 is a solution. So that would be 10 is less than or equal to 2 times negative 2 plus 4. 10 is less than or equal to negative 4 plus 4. Negative 4 plus 4 is 0. Is 10 less than or equal to 0? No, that's a false statement. Okay? So then, no, negative 2, 10 is not. Okay. All right, let's dive into it. Okay? So this is the one that I want to grab. Y is greater than or equal to negative 1/2 x minus 3. Okay? So again, I am thinking about this like y equals negative 1/2 x minus 3. That's how I'm thinking about it. If I'm thinking about it in that way, what is my y-intercept? -3, right? So I go down 3. What is my slope? So that means I do what? Down 1, right 2. Or I could go up 1 and left 2. Style of line, solid or dashed? Solid, because it's the equals component. Did I go through the origin? No. So I can use the origin. I wouldn't have to use the origin, but I can use the origin. I can use any point just as long as it's not on the line. I also put a little t kind of near where I'm testing, where my test point is. Okay? So if I plug in 0, 0, that's going to be 0, less than or equal to be greater than or equal to -1/2 times 0 minus 3. -1/2 times 0 is 0, minus 3 is -3. Is that a true statement or a false statement? That's true. Okay? So since that is a true statement, I am going to shade on the same side as my test point, because that is where it makes it work. Okay? If it was false, I'd shade on the other side. Maybe even some stars. Maybe even a smiley face. Okay? That's it, right? That's all it is. You want it to be more. You're thinking Liz is going to hit us with now. It's got to be something more, but nope.
I'm waiting for it.
Yep. Nope. That's it. That's it. You tried that one on your own. So I'm going to think of this as 2x minus 3y equals 12. So negative 3y is going to equal negative 2x plus 12 when I subtract 2x from both sides. Then I've got to divide every term by negative 3. So then that's going to give me y equals positive 2/3 x minus 4. So that gives me a y-intercept of negative 4. And the slope of positive 2/3 is up 2 and right 2. Excuse me, up 2 and right 3, 2/3. Up 2, right 3. Or down 2, left 3. Down 2, left 3. Down 2, left 3. Solid or dashed line? This one's a dashed line.
I didn't go through the origin, so I'm going to test the origin. 2 times 0 minus 3 times 0 is greater than 12. 0 minus 0 is 0. And is 0 greater than 12? That's a hard no, right? So that is false. So therefore, I now shade on the other side. Okay. Questions, comments, concerns, clarifications? That is all that I have for you for today. Okay? So I'm intentionally giving you a little bit more work time this week because I gave you a little bit more homework this week too. So you can start working on the homework and get yourself ready for Friday's test.